Hello guys, so in today's video we're gonna dive deep into some advanced manipulations of functions and absolute values and so on. Let's say mod x. Mod of 1 equals 1. Mod of minus 1 is also equal to 1. So from here we can say that mod of x equals x for all x's positive values, okay? And mod of x equals minus x for all x's negative values, okay? So this is what if x is equal to minus 1, it's 1. 1 is equal to minus of minus 1, right? So that's how you do it. So how do we solve these two? So this one, mod of minus 1 is 1. So plus 1, 2. And here, it's mod of minus 1 plus 1, which is 0. So let's say mod of x minus 2 is less than 0. So until you find mod x, you keep on doing it, okay? So mod x is lesser than 2, right? So now you get x is lesser than 2. So x is lesser than 2 and minus x is lesser than 2. So you already got the solution for this? Here, x is greater than minus 2. Okay? So this will be your answer. So the mod value of x must be less than 2. So that's what I'm trying to say, okay? Now you just do exactly like a quadratic equation. You'll get the value of x, okay? I mean mod x. Let's say the mod x value here is equal to 2 comma 3 something. Forget about this equation, okay? It's just a quadratic equation. We are getting mod of x equals oh, mod x equals 2 comma 3. So x equals 2 comma minus 2 comma 3 comma minus 3. So everything works, right? So now let's get into greatest integer factor. So now what we're trying to do is, uh, we're trying to eat this part. If it's positive, you eat this part. Actually, here it's minus. Okay, so here also you eat this part. If there's no this part, this point zero, then you don't have to worry. You can just write the same thing. Okay. So now if it's negative, you eat this part and you ignore this part first and add one. If you add one, it will become three, and then you take this part again. So that's what that's what gives you this answer. So we have flower bracket. Okay. So now if it's positive, you just put in the decimal value. If it's negative, you uh you do 1 minus the decimal value. Here you see only the decimal value. Here you see 1 minus 0.1, which is 0.9. I guess this makes sense for you. And then we have something called signum function. I guess you can just use this formula pretty well. If x is positive, then signum of x is 1, and if x is negative, it'll be minus 1. If x is 0, it'll be undefined. So we have onto and into functions, okay? So if the function has real roots, then it is onto. If it doesn't have any real roots, it's into, okay? Now the first one's onto because it has a real root. And second one's not onto because the roots are completely unreal, okay? So you have f of x equals x plus 2 and f of x equals x squared plus x plus 1. Now what you can do is you can take some random values for f of x. For example, 0, 1, 2, I'll prefer 0 because that gives you an equation. Uh, and also, no matter what value you take for f of x, it must satisfy. Here, if you take f of x is 2, it will satisfy for the second one. But if you take f of x is like 1 or 0, let's say, no, not 1. If f of x is equal to 0, the second one will be into. So you should try all the values possible, nearest values, okay? Now we have one to one and many to one. Now this is pretty easy for you to say, okay? So we can absolutely use decimal since SAT. So I'll just go in here and if it's a one-to-one function, no matter where you draw your horizontal line, it passes through only one point. So if the line intersects the graph in more than one point, then it is many to one. So this is many to one because this horizontal line intersects this one at many points. Okay. Now let's say x plus y equals 2. This is a line, right? If you zoom into the point, this is the only point where the horizontal line touches this x plus y equals 2. So now this is a one-to-one function, okay? So that's it for today, guys. Bye. See you tomorrow.